So Kaija, if I want to find f of 7, what's that going to look like? Did you hear me? Pardon? So if I'm looking at f of x equals negative 4x plus 3, and I want f of 7.
She hasn't finished.
Oh. Thank you, Jax. I couldn't hear what she was saying. Okay, so we're going to see that when we're asking for this notation, this is asking for, I need function f. When I input 7, what do I get out of it, right? So in place of the x, we're going to put a 7, right? And then we just simplify. Negative 4 times negative 7 is negative 28, plus 3 should be a negative 25. So f of 7 is negative 25. If I were to graph this, this would be the point 7, negative 25 on the graph of negative 4x plus 3, right? Next we have g of negative 8. Now notice every time I do a substitution, I put parentheses in, and in place of the x, I'm going to write the value inside our parentheses. What's half of negative 8?
Negative 4.
Negative 4 minus 3 then is negative 7. So g of negative 8 equals negative 7. This is the point negative 8 comma negative 7 on the graph of 1/2 x minus 3. Oh, and I see they forgot a little equal sign there. Okay? F of 1/2 means in place of x, we're going to have 1/2. So what's half of negative 4?
2.
Yeah, negative 2 plus 3 is a positive 1. This gets me the point 1/2, comma 1 on the graph of my function. Okay? We're just substituting and evaluating here. G of negative 1/2 so in place of x, I have a negative 1/2. What's 1/2 times negative 1/2? Yeah, negative 1/4. Top times top, bottom times bottom, minus 3. Now I'm going to make this 3 have a denominator of 4, right? So I can combine my terms, right? So that means it's going to be negative 12/4, which is going to give me negative 13/4. So this is going to be negative 1/2, comma negative 13/4 on the graph of my function. Now they want f of 6 minus g of negative 4. Okay, so that's going to be the structure of f, so negative 4 times my 6 plus 3, minus all of the structure of g with an input of negative 4. So 1/2 times negative 4 minus 3. So negative 4 times 6 is?
Negative 24.
Negative 24 plus 3, right? What's half of negative 4?
Negative 2.
Negative 2 minus 3, right? Negative 2 minus 3 is negative 5. Negative 24 plus 3 is negative 21. And negative 21 minus a negative 5 is like negative 21 plus 5, so negative 16. Okay. A lot of work here, but we're going to be doing operations on functions. This is lesson 6.1 in module 6. Module 6 is going to be all about inverses and radical functions and things like that. And it's going to prep us for our follow-on chapters 7 and 8, which are exponentials and logarithms. Okay? So, our standards are going to be combining standard function types using arithmetic operations. That's going to include adding, subtracting, multiplying, and composing, as well as division. So we're going to need you to be able to make sense of problems and persevere in solving them, model with math, and look for and make use of structure. So our goals are to find sums, differences, products, and quotients of functions, and then also to find compositions of functions. So one of the things we can do is we can add and subtract functions. And you've seen this when we have stuff plus stuff, stuff minus stuff, right? Okay? There's some special notation we need you to be aware of, but we're not really going to be doing much of the math with this because we've already covered the math. We just want to make you aware of the notation. Okay? So when I am adding two functions together, the notation f plus g of x, and I'm going to make sure that you guys understand this is f plus g of x, is going to be equivalent to taking all of f of x and adding it to all of g of x. So for example, if f of x equals 3x and g of x equals 2x minus 4, then f plus g of x takes all of f of x, which is my 3x, and adds to it all of g of x, which is 2x minus 4. We just combine like terms here, okay? Everybody good with that? When we subtract two functions, this notation means f minus g of x And we take all of f of x and we subtract from it all of g of x. So if f of x is 3x and g of x is negative 2x minus 4, then you're going to have 3x minus, and notice how all of g of x is in parentheses there. And we've got that minus outside of it, which means we're going to have to distribute that negative and then combine terms. So that's going to give me 3x minus 2x plus 4, which combines terms to be x plus 4. Now we've done this already, right? We're just giving you some new notation for that. Okay? The operations themselves are not new, we're just giving you notation for it. Multiplying f times g of x means you're going to take all of f of x and multiply it by all of g of x. Again, we've seen this before, where we have 3x times all of g of x, and then we have to distribute, right? And we get 6x squared minus 12x. We also have notation for f divided by g of x, which takes all of f of x and divides it by all of g of x, but we have to make a notation here that says g of x can't be equal to 0, okay? Or any numbers that make that bottom function equal to 0 are not included in the domain of f divided by g of x. So for instance, when we take 3x and we divide it by 2x minus 4, if I were to set 2x minus 4 equal to 0 and find out what x value makes this equal to 0, I'm going to find that it means x equals 2. So this means that if I use 2 as an input of this function, I'm going to get 3 times 2, which is 6, divided by 0, right? Not a great thing, right? We can't divide by 0. That's undefined, right? So that means that I have to put this little disclaimer here that says x cannot equal to 2. That's not going to be in the domain of this function. It'll in fact be a vertical asymptote. Okay? Everybody good with that? So example 1 here, we're on the page 299, bottom of page 299, says, hey, if I've got f of x equal to x squared, negative x squared plus 3x plus 1, and g of x equals 2x squared minus 5, we want to find f plus g of x and f minus g of x. So let's take a look at what that would look like. So I need all of f of x plus all of g of x. So that's going to equal all of f of x, negative x squared plus 3x plus 1, added to all of g of x. Right? Now since I'm adding, I really don't need the parentheses. And now I can combine like terms. So I have some x squared terms, I have one x term, and I have some constants, right? So that gives me a total of 1x squared plus 3x minus 4. Any questions on that? Everybody should have their books out, their notebooks out, be taking notes. Computers are not really a thing right now. Okay. F minus g of x is going to look the exact same. And to emphasize this, I'm cutting and pasting this over here. The only thing that's different, it's not a plus in between them, it's a minus, right? Does that make sense? I literally cut and pasted it over. The only thing that's different, instead of having a plus in the middle, you have a minus. Now I need to distribute that negative, which gives me negative 2x squared and a positive 5. Now I'm going to combine the same types of terms here, my squared terms and my constant terms, and that gives me negative, oops, wrong pen color, negative 3x squared plus 3x plus 6. Okay? Any questions on this? Notes for this are at the top of page 300. Now we're going to go on to multiplying and dividing these two functions. Same two functions. So this is going to equal f of x times g of x. So, oh no, actually these are different functions. So here f of x is 4x squared minus 2x plus 3. G of x is negative x plus 5. Times g of x, negative x plus 5. Now, if you wish to use the area model here, the box method, that's a great way to avoid losing some terms. So 4x squared times negative x is
4x cubed.
yeah, negative 4x cubed. Negative x times negative 2x is a positive 2x squared. Negative x times 3, negative 3x, right? And then 5 times 4x squared is 20x squared. 5 times negative 2x is negative 10x, and then plus a 15. And then we can see which terms we need to combine on our diagonals here. And that's going to give me negative 4x cubed plus 22x squared minus 13x plus 15. Moreover, we can see a quadratic with an x squared times a line with just an x gives me a cubic, right? Okay, let's do f divided by g of x. So that's going to take all of f of x, which is 4x squared minus 2x plus 3, and divide it by all of g of x, negative x plus 5. Now, we have to remember to say what x can't be if it's 0. What x value will make that denominator 0? If you don't know, take the denominator and set it equal to 0 and find out, right? So minus 5 minus 5. So negative x equals negative 5. I'm going to divide both sides by negative 1, so x equals positive 5. So this means that if I use a 5 right here in my denominator, it's going to end up being 0. Can I divide by 0? No. So this causes a vertical asymptote in my function, so x cannot equal 5. Make sense? Any questions? Okay. We're going to go on to what we really wanted to talk about today, which was composition of functions. Now, this is going to enable us to kind of look at functions and say, hey, we've got some structure to this. So we're going to suppose that f and g are functions. Oh, I hate it when we talk in mathies like this, such that the range of g, so the output of g, are a set of numbers that is part of the domain of f. So the stuff I get out of g is stuff that I can use in f without breaking f. Okay? We're going to see what that means more later, but we'll talk about it for now. Then the composition function f open dot g, which means f of g, can be described by f of g of x equals this outer structure f whose input is g of x. Okay, so I've got an outer structure of f of x, right? And inside it, I'm putting g. So the input of f is the output of g, right? And in reality, what happens is I work these things from the inside out. I put an x into g of x. So an x goes into g. And then what I get out of that gets put into f. Okay? Now, example 4 is not one of my favorite ones, but okay. Yeah, I'm going to put it in this drawer right here. You're welcome. Are you going to be back this afternoon? Okay. So here we are given two functions, f and g. We want to find f of g of x and g of f of x and state the domain and range of each. Now, these functions are kind of wonky because f is just a set of 4 points and g is just a set of 4 points. Okay? I'm going to open up a separate page for this because this is kind of wonky. So our first problem asks for, whoops, wrong pen, f of g of 4, okay? And they want to know what that equals. Well, if I look at an x value of 4 in g, right, what do I get out of that? I get out a 1, right? Everybody good with that? So that's going to equal f of 1. Now, if I put a 1 into f, what do I get out of that? 12, right? Everybody good? I know. Okay. Let's go back. I'm working it from the inside out, so I've got a 4 that I'm putting into G. So I'm looking at all these values of G, and I'm trying to find which of the X parts equal 4, right? I've got four values. Which one equals 4? That's 4, right? So the X's are inputs, the Y's are outputs in these coordinate points. Everybody with me? What do I get out when I put a 4 in? I get a 1 out, right? So G of 4 equals 1, right? So now my structure just becomes what is F of 1. Okay? I put in a 4, I got out a 1, right? Now, I'm going to say in my F, where do I have an input of 1? Oh, hey, it's right there, right? What do I get out of that? 12. I'm erasing all of this so we can start again on the next problem. The next problem asks for f of g of 5. I'm going to write this f of g of 5. Okay? Maybe you can see that better. What is g of 5? That's a 5, right? What do I get out of that? 0, right? Marcus, you with me?
Yeah.
Okay. Luke, you good with this?
Yeah.
Okay. You're not just saying yeah, because this is tough.
I got it.
Okay. So that means I'm looking, when I'm moving out in all of this, I need f of 0, right? Caleb, what if I put a 0 in my f, what do I get out of that? 13. Okay? Because we have a 0 here as an input, and we get out 13. Okay. Jax, you good with this?
I think I'm done with it.
Okay. We got several more to do. So, third one down says f of g of 13. Okay. So, Elena, what is g of 13?
9.
So really what my expression is asking for now is f of 9, right? And what is f of 9, Marcus?
Would it just be
So we've got an x value of 9
yeah,
in f. What's my output?
on number 3, right?
Yeah, like, okay, let's look at this. X comma y, right? Input, output. Okay, so we're talking the same language, right?
Right.
Okay, so if I put in a 9, what did I get out? A 7.
I could not see that.
Okay, you got your book open?
Yeah, I have no word.
Okay, yeah, because,
Is it on the book?
yeah, it's on the top of page
Oh,
301.
yes, okay, I see it.
Okay. So we're going to get out a 7. Okay, next one. This is f of g of 12. Okay. Erasing all of this. What is g of 12, Marcus? 10. So g of 12 equals 10. So this is really asking us now for f of 10, which is what, Jax?
11.
11, very good. We seeing it now? Okay, next column. Now we're backwards. So we want g of f of 1. So I'm putting a 1 into f. What do I get out of that, Luke?
So 1?
Yeah, 1 into f.
12.
12, right. So f of 1 equals 12. So this is asking us for g of, oops, wrong pen color. G of 12 now, right? And what is g of 12? Caleb? 10. Okay. We're seeing how to do this. Next one is g of f of 10. Marcus, what is f of 10?
11.
11. So what we're asking for now is g of 11. And what is g of 11? Do we have an x value of 11 in g? No. So this is undefined, right? Okay, so what we got was we had an output of my inner function, 11, that was not an input of my outer function, right? G. Okay, so that was what we were talking about when we said, suppose f and g are functions such that the range of g is a subset of the domain. We have to have stuff that are outputs of the inner function that we can actually use in the outer function. Otherwise, life gets crazy. G of f of 0. So, what is f of 0? Thirteen. So f of 0 equals 13. So we are asking now for g of 13. And what does g of 13 equal? 9. The last one is g of f of 9. So what is f of 9? Seven. Very good. So now we need f of 9 equals 7. So we are asking for g of 7. Do we have a g whose x value is 7? No, so it's undefined. Okay. So 11 and 7 are not in the domain of g. So g of f is undefined for x equals 11 and x equals 7. So g of f just equals 1 comma 10 and 0 comma 9. So we want to state the domain and range. When we're looking at f of g, the domain is the x coordinates of the composed function. Okay? So they were all the numbers that when I could put them into this inner value here, we got outputs, right? Okay, and it turned out those numbers that I could use in that inner x were 4, 5, 12, and 13, right? And what we got out was a 7, 11, a 12, and a 13, right? So that's my range. Okay, everybody good with that? When I did g of f of x, okay, the only numbers that I could use were 1 and 0 in here, and the numbers I got out were 9 and 10. So I think you had some blanks here. That you need to fill in. So the nice thing about this is you kind of see the inside-out nature of things, right? If I'm evaluating f of g of something, right, I start and I put that number into the inner function, and then what I get out, I put into the outer function, right? So let's see how this works with actual functions, and that's going to be working with example 5. So I've got f of x is 2x minus 5, and g of x is 3x. We want to find f of g of x as well as g of f of x. And then we want to state the domain and range. So I'm going to look at f of g of x, which is equal to f with the outer structure and g of x with the inner structure. And then I'm going to look at g of f of x, which has the outer structure of g and the inner structure of f, right? So when I say it's got an outer structure, this means that everywhere I have x's in f, what gets put in those x's is g of x. Everybody good with that? And everywhere I have x's in g, for this other one, I put all of f. So this is like saying f of 3x. This is like saying g of 2x minus 5. Okay? Now, we will distribute and combine like terms and end up with 6x minus 5 here and 6x minus 15 here. So you can see they're two different functions. These two happen to be parallel, but that's not always going to be the case. Now, state the domain and range, right? Both of these are lines with infinite domains and ranges, so we don't have any limitations, and we got lines out of them, so my domain and range are both all real numbers. That's not always the case, as we'll see with the check problem. So my domain is all real numbers, and my range is all real numbers for both of these functions. Okay. So here we have f of x equals negative x plus 1. This is on the top of page 302. And g of x equals 2x cubed minus x. We want to find f of g of x and g of f of x. Okay? So let's first look at the structure of f. So f of g of x. So I have a negative x plus 1, and inside that is going to go all of 2x cubed minus x. Okay? That's going to equal negative 2x cubed plus x plus 1. Okay, this is a cubic function. What's a domain of a cubic function? Marcus, what do you think?
Domain of the cube function.
Mm-hmm.
I don't know.
Okay, is it a polynomial?
I think so.
Yeah. And what's the domain of every polynomial function?
All real numbers.
Yes. And what's the range of a cubic function? Who knows? It's also all real numbers, because it's going to look like either there's a squiggle like this or a squiggle like that, right? I've exaggerated the squiggle-ish type. It's really not that wide, but which one is it? Right hand going up or right hand going down? You guys remember this? We know that we have a cubic function, and what's my leading coefficient? Negative 2. So is the right hand going up or down? Down. So it's going to be this one, right? Okay? Now we're going to do the opposite of that. So we're going to have g, oops, wrong pen, g, whose input is f of x. So we're going to have the structure of g, so 2 times stuff cubed minus stuff. And the input is going to be all of f, so negative x plus 1. Right? They give you oh so much room to figure this out, but they're actually going to want you to cube negative x plus 1, which means you got 2 negative x plus 1 times negative x plus 1 times negative x plus 1, and then plus x minus 1 after we distribute that. So that's going to be a lot of math. Okay? How would we do this? Do you guys remember this? We're going to have to watch Ferris Bueller's Day Off because I'm feeling too much like the teacher in that class. No clue. Nobody has any clue? We good? Anybody have any idea how to deal with this structure here? 3 sets of parentheses.
Distribute the 2 with the first one,
Mhm.
then box method, next one, then the answer you get from that box, but then the last one.
Right, and then multiply everything by 2, right? You guys remember this? We have tested on this twice now, Module 4 and Module 5. Okay, so we're going to take these first 2 parentheses and we're going to multiply them together. And that will give me an x squared minus 2x plus 1. Okay? And then we've got negative x plus 1 times all that. So then we're going to have to make sure those get multiplied together, right? And then we're going to multiply everything by 2. And then we're going to combine terms with our x and our negative 1. Right? Does this look familiar? Luke, have you seen this before?
Yeah.
Okay. Now, in this is just going to be a cubic function, right? What is the domain of a cubic function?
Is it all real numbers?
Yes, it is. It's always all real numbers. What is the range of a cubic function?
All real numbers.
All real numbers, always and forever. Every line, every cubic function, every function to the 5th power, right? All real numbers for everything. If you're going to guess on something, please guess all real numbers. Okay? The only thing that is not all real numbers for domain and range is range when you have a u-shaped function. So an x squared or an x to the 4th, right? Then that's going to have either a definite bottom, if we're smiley face, or a definite top if we're frowny face, concave down, right? Okay? Those are the only differences. That's why polynomials are so nice. Okay. So, that's what we end up with once we do all that math. All real numbers, all real numbers. Okay, I'm going to check something here to see if we're doing okay, we are not going to do this last example because it's not something we're going to be testing. Okay, so I am going to go ahead and assign the homework for you guys. In McGraw-Hill, the problems are going to be match the operations on the functions. 2x plus 5, 13. $14. 16. 21. 25. And then there's an additional problem at the beginning, which is problem 1. So 1 comma 13, 14, 16, 21, and 25. Okay? Yes,
Can I go to the bathroom?
yes. And then I'm assigning that homework right now to you. So today is Tuesday. It is going to be due next Monday. Because I'm applying it to all my classes at the same time, it'll show as next Tuesday in McGraw-Hill, but I'm going to start putting the grades in next Monday. So you get one class period to ask questions, and then it's due the next class period. Okay.